negative, it's downward.
That's right. That's right. So it is that downward one.
Mhm.
Okay. There's a couple of ways to graph this. The first is to like know where the vertex is. Second is other ways like with transformations. Since you've got to do the transformations, there are one, two, three, there are four transformations. Can you give any of them to me? And they don't have to be in the right order, but do you can you give me any of the transformations that you see?
Um, I think it's like go up 3 and like
Okay. Three is the last one. Good.
and I think right 2. I don't know.
So left one is the first one. That x plus one is left one. Now the ones inside parentheses are kind of like the opposite of what you think they should be. So plus one, you might think, oh, it's right, but it's actually left.
Mm-hmm.
Um, the two here is and actually let me start color coding these because this, you might want to look this later on. The two there, the negative there, the plus three there. Okay. So
Mm-hmm.
the two is a vertical stretch, very important, vertical stretch
Mm-hmm.
by a factor of two.
Mm-hmm.
Okay. Now your teacher might be okay with just stretch two, vertical two,
Yeah.
only you know what they want. I don't know what to tell you. You have to go with whatever they want. The
Yeah.
negative out in front is a reflection over the x-axis.
Mm-hmm.
Okay, now could be that that is enough to just say reflection. I think you have to specify the axis and so on. So those are transformations. That is actually enough to be able to graph it, but the better way to graph it is to first determine the vertex. Do you know what I mean by that? What the
Yeah.
vertex is? So in this case, it comes from the left, right, and up, down. It's -1, comma 3. So your vertex is right there. All right. Now, the thing that maybe isn't made clear in class, and this is kind of a shortcut, is these lines, like the ones that go down or the ones that go up, they have a slope equal to this number in front. So the slope in front here of -2 means you're going to go from this point up here. You're going to go down to right 1. So
Mm-hmm.
down 2, right 1, down 2, right 1, and so on. Oops, that's there, and so on like that. Okay.
Mm-hmm.
Now the other way is symmetry. So it's going to mirror image it.
Yeah.
So, you don't have to get too, fussy with this, but that's now if I'm grading you, I'm looking for the shape. I'm maybe looking for one or two correct points. I'm not going crazy on this where I, want it to be so perfect, but
Yeah.
it's gonna kind of look the part.
Mm-hmm. Okay. Okay. And then the domain and the range.
Yeah, so until otherwise, the domain is all real numbers. It's everything.
Yeah. And then like the
The,
range. Yeah.
the range depends on whether it opens up or down. Okay, so the range, if it opens up, okay, is the y coordinate of the vertex to infinity. If
Um,
it opens down, it's -infinity to the y coordinate, like that. It depends.
mhm. So it would be -infinity to um uh, 3 or
Yep,
yeah.
with a bracket.
Mhm.
Bracket is important. Bracket means it's included.
Yeah. Okay.
Okay, let's do like maybe not the whole thing, but let's focus on the transformations because I can see that that's going to be an issue here.
Yeah.
So let me give you another one here. Let's say it's like y equals 3, absolute value x -4 -2. So this one has 3 transformations. Let's see if you can give me any of them, all of them, some of them.
So would it, so I know the last one is down to,
Okay,
and then, um, left 4,
right 4.
oh, right 4. And then,
Now
um,
this 3 out in front is the vertical drag
okay,
by 3.
okay. So if they're in front, does that mean like they're all like stretches?
It looks like all of yours are
Mm.
that, but that generally no, like that's not. So,
Mhm.
the one inside parentheses here though, left or right,
Mhm.
this is up or down. This number out in front, if it's greater than 1, it's a
Mhm.
stretch.
Okay.
If it's between 0 and 1, it's called a compress. Does that
Yeah.
look?
Yeah. 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 Okay. Yeah, that makes sense. I don't know if you're like cutting out or something, but I can't
No,
like.
just pausing, just
Okay.
pausing.
Yeah.
I'm trying to decide how much more we should do on this or not. So let me give you another one here. Let's say it's y equals -1/2 absolute value x plus 1
Mhm.
minus 2. This one has 4 transformations. Can you give me those?
So compression by 1/2,
Okay. Compress 1/2.
and then
And so you're supposed to add the word vertical. That does matter, although it's not super critical. Vertical compress 1/2.
and then reflection of x for 1,
Yes, reflection x-axis. Good.
and then left by 1,
Okay.
and then down 2.
Down to good. Okay, really good. All right, so I feel like that's a pretty good thing here.
Mhm.
Um, a graph. Now, why don't you look at 10 through 15? We did 14. Why don't you look at 10 through 14 and
Mhm.
decide if there's any uh
Can we do 10?
yes. So 10 is this awkward problem where it's a line. Notice there's no square, there's no absolute value. Like this is an equation of a line.
Mhm.
Lines don't really have transformations, okay?
Mhm.
But it kind of has this form of a transformation where you have this x minus 3,
Mhm.
you have this 2/3 out in front, and then you have this plus 1. So let's just go with like the same rules that we've been using for that.
Mm. So would it be like compression by 2/3 or
Yes,
okay.
yes. Vertical,
Mhm. And then up 1,
okay, up 1, good.
right 3?
Yes, good. But that's like, this is weird to graph. Like you would never graph it this way. To
Yeah.
graph an equation of a line, you really want it to be in this form, y equals mx plus b.
Mhm.
Okay. Now to get it in that form, you're going to distribute,
Mhm.
you're going to distribute this 2/3 to both inside parentheses. So this is 2/3 x. 2/3 of 3 ends up being -2 plus 1. This is 2/3 x minus 1.
Mhm.
Okay, now I think if that's something you're unsure about, we can do a couple more problems like this. Just have to let me know. But from here, you need the slope and the b value.
Mhm. So the slope is, or yeah, the slope is 2/3,
Okay.
and then -1 is the b.
Yes.
Yeah.
Yes. All right. Now, you start with the b value. You go to the graph. There's the b value,
Mhm.
and then you use the slope as the rise over the run. So this means up to right 3. Up to right 3. So up to right 3, up to right 3 like that. The domain until otherwise is -infinity to infinity.
Mhm.
The range, well, depends on the problem. So for lines like this, it is always -infinity to infinity. So
Mhm.
this applies to lines.
Yeah. Okay. I got that.
All right. We should do 16, 17, and 18. They're pretty quick.
Mhm.
Um, and they'll answer some questions about domain and range.
Yeah.
All right. So the domain refers to the x. So you go to the leftmost x value right there, which is 2. And
Mhm.
then, how far to the right does this go? Well, it goes
Infinity.
forever.
Mhm.
Okay. So the domain here is 2 to infinity. And then the question is like, does it include 2? So when you have an open circle or an infinity or a negative infinity or this symbol or this symbol, you always use
Uh-huh.
parentheses. But if you have a filled in circle, greater than or equal to, less than or equal to, you get a bracket or a bracket. But in here, it's 2 is not included and infinity never gets one.
Yeah.
Set notation would be x greater than 2. There is some other stuff that you're supposed to write there, but that would be, I don't know if your instructor wants that.
Yeah, no. We just did the x plus, or
Okay.
yeah.
So for the range, you go to the y's,
Mhm.
-2. And then it's like, well, how far up does this go? Well, it goes up to positive infinity. So it's -2 to infinity. Infinities always get the parentheses. The -2 gets a bracket. Nope, sorry, no bracket this time. Is not included because of that open circle there.
Yeah.
The range is always the y greater than -2.
Okay.
All right, let's look at 17 here together. Okay. So the domain here, we're looking at the x's. What's the smallest x value there?
0.
0. But actually, we need to go further left. So how far left does this go?
Infinity.
Negative infinity. Negative infinity. Like left is negative infinity. So it's negative infinity to 0,
Mhm.
but this time it includes 0.
Mhm.
And so this time it's x less than or equal to 0.
Okay.
Now let's talk about the y's. The y's for the range. What's the smallest y value there?
0.
0. And then how far up does this go?
Um, Negative infinity.
Well, it's going left to negative infinity, but it's in terms of going up, how far up does it go?
Oh, then just infinity.
Yeah, and this is the challenge. Like you have to switch your thinking from x to y.
Mhm.
and so on. So y is greater than or equal to 0.
Okay.
All right, now probably not fair to do, but I'm gonna have you try 18 here on your own.
Okay.
Um, just this one is bounded on both sides,
Mhm.
meaning like it doesn't go to infinities. For the domain, we're just looking for the x's, the x values. For the range, we're looking at the y values. Take a minute or two, see how
Okay.
you're doing on that.
Mhm. So for like the set notation, how would
Don't worry
I?
about the set notation. Let's just do interval. Do interval for set we'll get to. That's like I'm looking for the left and the right on the
Mhm.
domain.
Okay. So bracket 6, 8 parentheses.
You said bracket 6, 8 like that?
Yeah.
Okay, let me show you on the graph where that is so you can make the appropriate change. So you're saying it's only valid from the red part to here. That's what you have. So I
Oh,
think you meant
yeah.
-6, right?
-6.
Yes.
Yeah.
Okay. Yes. It's a small thing, right? But if it's
Yeah.
multiple choice, you might have both. That looks good. How about the range?
And then um um is it bracket 3, 4?
So same issue on this one. 3 to 4 is like it's like there to there.
Yeah. -3.
Yes. And maybe you're writing it correctly and saying it wrong. That would be okay because it's what you put down on paper. Now, this one's kind of easier. You put the left bound, you put the right bound, and then if it's included, it's a less than or equal to. If it's not included, it's a less than.
Okay. Okay. And then
And how about give me the range now?
um -3. Uh, I don't know.
All right, less than or equal to because it includes that,
Hmm.
and then y, and then less than the other y value, which is 4.
Okay. I think I got that.
We can always do more. These like but it is. I mean, we got other stuff to get through as well.
Yeah.
When is your test or quiz
Um,
retake?
I can like take it whenever I want.
Okay,
But
all
yeah.
right. All right, we're gonna do 27 first, and then come back to 26. That's
Mhm.
okay. All right. So what I'm seeing here, this is a piecewise graph. It has 3 pieces: piece 1, piece 2, and piece 3. The
Mhm.
very best way to do these um, is to break this up into pieces. So like the first one we're going to do for x less than 1. So what I recommend is making a table of x and y values, and you start at the first x value there, which is 1.
Mhm.
Okay. Now at 1, because of this symbol right here, and we made this chart earlier, this
Mhm.
symbol right here, it's going to have an open circle
Mhm.
there because of the less than.
Okay.
So I denote that. I say, okay, it's going to be an open circle.
Mhm.
And we want numbers less than 1. So like 0, maybe -1, -2, like that. We
Mhm.
want a few things to graph, okay? So we want to evaluate each of these x values in here.
Mhm.
So like, could you try that for me, please, and tell me the y values?
Yeah.
And I'm going to step away for just 10 seconds, but maybe you can work on those. Be right back.
Mhm.
Let me know if you have any questions or if you got some answers.
Mhm. Um, okay, I got 1 and 0, 0 and 0, -1 and 2, and then -2, -1.
Because I feel like we're missing the whole point of what this absolute value means. Do you show from class? Uh, the absolute value of like -1 is 1.
Yeah.
So if it's absolute value of 1 minus 1, that becomes 1 minus 1.
Oh.
It always returns a positive number.
Uh-huh. So how do I make that in a y value? Oh, it's just
0.
Oh.
An absolute value of -2 minus 1 becomes 2 minus 1, which is 1.
Okay.
So we go to this point 1, 0 and open circle. So an open circle at 1, 0, that's right there.
Mhm.
0, -1 is a filled in dot. -1, 0 is a filled in dot. -2, 1 is a filled in dot. So like just keep in mind this one is only good for x less than 1. So like you're limited to just looking left of that red line. Like
Mhm.
you don't go right of it, you just stay left of it. And if you remember the absolute value is some sort of v, so this v's and goes like kind of like that.
Okay. Yeah.
Is that somewhat okay?
Yeah.
All right, now we go to the next piece. The
Mhm.
next piece here, do it in blue. The next piece here again, make a table. X and Y, make a table. Now it says it's good from 1 to 3. So maybe just 1, 2, and 3.
Mhm.
The Y value is always 4. That's what this means. It means Y is always 4,
Mhm.
4, 4, 4. And then see how it's less than or equal to here?
Yeah.
That means that it's a filled in closed circle on both sides. Closed circle, closed
Okay.
circle. So we go
Yeah.
to that point, 1, 4, like that. 2, 4, 3, 4. It's some sort of horizontal line there, like that.
Mhm.
Then we go to the last one. And I have to bring this down. I don't have enough room here for this. 2x minus 3 for x greater than 3. So again, you make a table.
Mhm.
You start at whatever value you're given, which is 3. Because it's a greater than, it's an open circle. I like to write that down so I don't forget. And then we need numbers bigger than 3 this time. Okay. Like if you keep wondering, well, how does Matthew picking numbers in the table? It's based on the inequality. Less than 1, numbers less than 1, 0, -1, -2,
Mhm.
1, 2, 3, 3, 4, 5. I can't tell you how many you need, but
Yeah.
that'll be kind of dictated out of this. So can you give me the Y values here from putting these numbers into the table, please?
Yeah. Um, 3, 5, 7.
So you got it. Okay. So we're gonna go to 3, 3,
Mhm.
open circle, 4, 5, which is not an open circle. And then right there, And again, this one's only valid to the right, so you only show it to the right like that.
Mhm. Yeah, that makes more sense.
Right. Do you want us to do 26?
Yeah, we can just do one more.
Okay. Do you want me to make like one up that's a little more difficult than 26 or like more like 27, or do you want us to just go with what's there?
We can just do it how it is, I think.
Okay. All right, so number 26. Okay, so just like the previous ones, you're going to make a table for each. So we're going to do that for the first one here.
Mhm.
So this one goes from -6 to -2. So you could actually put in all of those X values if you wanted. Sometimes you only put in the like endpoints.
Mhm.
This is an open circle. This is a closed one.
Mm.
All right. So what is the Y value for all of these?
-2.
-2. So graphically, it's a horizontal line, -6, -2, and then -2, -2 like that. And then it's everything kind of connected in between.
Mhm.
All right. So the middle one, switch colors here. Switch colors here. So again, table X and Y. This one goes from -2 to 2. Yeah, sometimes you don't need to put all the numbers in between.
Mhm.
Again, this is open, this is closed. It's based on the symbol, that symbol and that symbol. And one is the Y value at both. So the teacher is grading you not just on like drawing this, but they're really looking for the open and the closed there. So
Mhm.
-2, 1 is open, 2, 1 is closed, so something like that. And then the last one there, if you like having colors, I would recommend doing that on the test.
Mhm.
It'd be very helpful. 2 to 6, 2 is an open, 6 is a closed circle, 3 and 3, 6, 3, like that.
Mhm. Yeah, that's much more clear than how he explains.
Well, that's a great testimonial for the business, which I like hearing. So we probably should do 28 if it's a going backwards problem.
Yeah,
And yeah, let's see here. So how many pieces do you see? How many pieces are there based on this graph?
3.
3. So your function is going to have piece 1,
Mhm.
piece 2, and piece 3. And it's separated with a comma. And we're actually going to do this part first, the inequality first.
Mhm.
Okay, so you have to go to like those breakpoints.
Mhm.
Okay, now this first one over here is good for what X values? Could you just tell me verbally kind of what you see here as far as what the X
Negative,
values are?
or it's negative, like -2 or like greater than that. I just don't know how to say that.
So that would be to the right. Greater than would be to the right. It is -2, but it's to the
Left, so it's less than.
yes. So this is X less than -2. Is it less than or equal to?
It's just less than.
Good. Okay. Now piece 2 goes from that X value to that X value there. this is a between. So what two numbers is it between?
-2 and 1.
Okay, and are they included or not included?
Or included.
Yes, so that's this symbol right here when they're included.
Mhm.
Last one here.
Um, would it be x is greater than 1?
It would if it went forever to the right.
So I don't know.
You do know, come on, like it's no different than this one. It's just that it's got an open circle and a closed circle. Like it's two numbers.
So is it 1 is less than,
Yes, good.
and then it's less than 3?
Okay, but three is included, so it's less than or equal to.
Oh yeah.
Okay, good. All right. Now, if we had to give a verbal description to each piece,
Hmm.
what would you call this down here?
Um, I don't know.
Okay. Well, you go to the grocery store, right? Or you go to Walmart and you buy you want in the front they got the fruit section now. At least that's when where does I go? Like, yeah, this is all fruit, right? But maybe this could be better described as an apple or a banana or like what's give me here. We've graphed some of these earlier. What is this? What's a name of what's something you could call this?
Oh, um,
I'm not trying to be difficult here. Like these are just
um,
something they're what did we graph in this problem here? Or not this problem, sorry. What did we graph here? What is this called?
a line?
A line. So these are lines. Line, 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 right? Sometimes it's good to not overcomplicate it. It's a line. Okay.
Mhm.
Now the two on the right, they're not even lines. They're like just numbers.
Mhm.
So we graphed that in the previous problem. See how these numbers give the height of the line?
Yeah.
What is the height of this line here on the right?
3.
3. What is the height of this one here?
Um, is it -1 and 1? But
Why was the height of this one 3? This one on the right. Why was its height 3?
because that's like where because it's,
Like I'm looking at this. That's its height. The height is 3. How far up from the x-axis is it? It's 3 up. How many up from the x-axis is this one?
1.
1. Now for this last one, it's of the form mx plus b.
Mhm. Um,
So what is the slope? And you don't have to get to an equation. You can literally just do rise over run, rise over run. What is the slope of this line here?
just 1.
Just 1. So we can turn that into a 1. The
Mhm.
b value you get by extending this. If you were to extend it, where would it hit the y-axis?
Um, just 0.
Yes. So b is really 0.
Okay.
Thoughts on that? Questions?
No, I think that makes sense.
Okay. It'd be good to do more like it.
Mm.
I don't know if we have time for that, but we can certainly work on some more problems. Like 30 would be the next problem to work on. Um, 30 is an exception though.
Oh, yeah, no, those ones I get. It's just more the graphing ones.
Okay.
It's like
All right,
30.
let's look at 31 then.
Yeah, I don't know what I was doing there. I guess that's not a piecewise function.
Okay, so the first thing is you just treat this as y equals mx plus b, or y equals minus 2x plus 4. What is the slope and what is the b value for this one?
2 is m.
It's more than that. There's this other little thing in front.
Oh, -2.
Yes, it's huge. It's like parking on the wrong side of the street.
Yeah.
It's a big deal. How about the b value?
4.
Do you remember which you start with when you graph the b value or the slope?
The b.
So you go up to 4, and
Mhm.
then the slope tells you what in this case when it's negative?
Um, go down.
Down 2, and
Mhm.
then it's always to the right.
Mhm.
So down 2, right 1, down 2, right 1, and so on. Now, whenever it's this symbol or this symbol, it's a dashed line.
Uh-huh.
Whenever it's this one or this one, it's a
So,
solid. So which one is it in this problem?
uh, dashed.
Dashed. Okay. Okay. Now, next thing, super, super important that if you have solved it for y, and this only applies when you solved it for y,
Mhm.
which means it might be worth solving it for y. Only applies if solved for y.
Mhm.
If it's y less than or y less than or equal to, this means to shade below. Y greater than or equal to means to shade above.
Okay. So we shade below.
Yes. Now, what I would recommend is just putting little arrows to show that you're shading below for the
Uh-huh.
moment, and then we'll do the other one. So I'll do that. I'll do that in different color here. All right. So what is the slope and the b value of this one?
Um, the slope is just 1,
1/1 b value.
-4.
Okay. So we start. Is it a solid or a dashed line?
Dashed.
Dashed. So there we go. We got some points. So look something like that. Now, based on the inequality, do you shade above or below it?
Below.
Below. So when I draw these like little arrows, you can draw more if you want, but you see how there's 4 regions. There's kind of this top, left, right, and down below.
Mhm.
Which one am I shading?
Um, 3.
Yes.
Yeah.
And what I know probably in class they're having you shade the whole thing. I would wait until you know for sure which one it is. That's why I
Mhm.
draw these little arrows. It's not too big a deal to graph and
Mhm.
shade. Questions, thoughts on that?
No, that makes sense.
All right, so 32 is a lot like 31, except that the first equation is not solved for y, which means
Mhm.
you probably ought to solve it for y. It's not too difficult to solve for y. The things that I talked about shading these rules, again, you have to solve for y. Like they only work when you solve for y. So to solve this one for y, you're just going to subtract x from both sides. I recommend putting it in front of the number there, so it's y less than or equal to minus x plus 4 like that.
Mhm.
What is the slope? What is the b value?
The slope is 1, oh, -1, and the B is 4.
Okay, so is this a solid or a dashed line?
Dash. I mean, solid.
Solid, yeah. Really, it's easy to mix them up, and they mark you off for that.
Yeah.
So the solid line here, you're going down 1, right 1, down 1, right 1, so on, so on, so on. The dashed, like that, except it's solid. What am I doing? That is terrible. Okay. Do you shade above or below this line?
Um, above
It's
or
less than or equal to, though.
below.
So
Yeah.
that's a below. So, left, left. Um,
Mhm.
Now the next one here is already solved for y.
Mhm.
So its slope is, b
2,
value is, what's the slope? What's the b value?
Slope is 2 and the b value is -4.
Good. All right, so down 4. So slope of 2 means you're going up 2 over 1, up 2 over 1. Now this is a solid line.
Mhm.
Now do you shade above or below it? And it's this one over here.
Shade above.
Yeah. So it's kind of, again, there's like 4 regions, which one is it? 1, 2, 3, and 4. Which one would it be?
Would it be 2?
It is 2, yeah. Good.
Yeah, that's a lot easier than I thought.
Okay, so that takes care of everything on your paper. You have other stuff you want us to look at? Do you want us to go back and look at the ones we didn't do? What would be best for you?
No, I think I got the hang of it now.
We do have some more time. I mean, I'm not trying to close our, but
Yeah.
I don't know. I mean, if your test is like this, you're going to be uh, uh, um, it's I don't know. It's like maybe, these are good enough. I don't know. You got a bunch of problems that we didn't do. I mean, is everything else clear on there?
Yeah, it was just like the graphing I was like struggling with, but I think it makes more sense now.
All right. Well, I do have some openings, or later this week.
Mhm.
If